We are on to lesson 2, measuring 2D shapes, perimeter and area. Our goal today is to determine the perimeter and area of 2D shapes. In the previous lesson, we looked at linear measurement and we convert one unit to another. So, in the previous lesson, we looked at converting 2.7 meters to centimeters. And we use a standard conversion factor, 1 meter equals 100 centimeters, to determine how many centimeters in 2.7 meters. We also looked at non-standard measurement, where there is no standard measurement because it varies according to the situation. In this case, we have at a rate of 80 kilometers per hour, how far will you travel in 6 hours? There's no standard speed you can travel or rate you can travel with a car or any vehicle. So this is called a non-standard. When we have a standard one, such as 10 centimeters equals, 10 millimeters equal 1 centimeter, or 100 centimeters equal 1 meter, that's a standard unit. So we looked at how to determine this, either converting meters to kilometers or finding the rate or how far you travel using non-standard measurement. Today we are moving into finding perimeter and area of two-dimension shapes. Now, a 2D shape, or we refer to two-dimension shape or 2D shape, is perfectly flat. It's two-dimension. There is no depth to it. In other words, it doesn't have any depth. For example, if I were to put a cube here or anything that has depth to it, for example, this marker here, that has depth to it. You can measure, it has, and this is what we call the 3D objects. We're not going to look at 3D objects yet. We look at that later on. So, for example, if you look at this paper, now there is a depth to it, but it's really flat. We refer to as two-dimensional objects. So a rectangle, for example, would be a 2D object. There's no depth to it. So if it looks from the side, you'll see nothing. There's no height. Same with the square here. You can't see anything from the side looking this way. But you can, from the top, you can see there is a length or a width, whichever way you want to look at it. Here we have this width or the length, and this would be the width. Here we have the base, and we have a non-perpendicular angle. A circle is a different one because it has a curve, not a straight line. So these are referred to as 2D objects. Now, they have names because they have a specific shape that we can put a name to. A circle is a curve. So it's basically a curved line that's connected. Or in mathematics, there's the infinite amount of points from a specific point here, from center, we'll refer to as a circle. But when we have regular shape, there's no name to it. But for the other ones, but we can still find the perimeter of these here. We can still find the area, which we'll recognize as a space in between, or within, I should say, within this object. The space within this object will be referred to as the area. What's the space in here? The area. the distance around the line here we refer to the perimeter. So we can find those. So that's this lesson is all about. How do we go finding the space in between here called the area? How do we find the distance along these lines, which is called the perimeter? So perimeter and area, that's our intent today, is to determine the perimeter and area of 2D shapes. We'll be looking at these 4 names, ones that we can name to, and then we look at ones that are irregular. One thing I must remind you, at the back of your booklet, you probably have, it's a formula sheet for reference. It's the way the back of your booklet. So if you check in your booklet at the back of it, you'll find a copy of this formula sheet. There are 2 sides to it, and the other side give you surface area and volume. We'll be using these formulas as we get into lesson 3 and 4. So keep that in mind. We'll be using these today, in the future. So let's look at determine the perimeter of a rectangle. Now, as we mentioned, the perimeter is the distance around any shape, or also on these lines here. There are a couple of ways you can get this done, but we'll do it the long way, and I'll show you the shorter way. Now, this is a rectangle, and in a rectangle, so we call this a rectangle, the opposite sides are equal. It means the side is equal to this other side. So this would be 4 centimeters. This side would be equal to the other side. So we label the side. We can refer to this as a width, and this is their length. So even if we by definition, the opposite sides of a rectangle are equal, because this angle here, as we learned from our trigonometry, this side is perpendicular. So the width is perpendicular to the length. This is 90 degrees. All 4 sides are perpendicular. Vertices here. All these vertices here are perpendicular to 90 degrees. To find the perimeter, which is the distance, right? So perimeter is distance around an object. And we're looking here at the 2D objects here. We have the length, the 2 length. So perimeter will be equal to the 4 centimeters plus 2 centimeters plus 4 plus 2. Plus 4 plus 2, 6, so 6, 12 centimeters. Or there's a formula that we can use, which is perimeter is equal to 2 times the length, and this is a rectangle, plus 2 times the width. And this only applies for rectangle or square. We'll see it also applies to square. Two times the length, 2 times 4. plus 2 times the width, which is 2. 8 plus 4, which is 12. So you end up with the same result. The formula works well for any kinds of 2D shapes that we know we have a name for. Other ones, we will not be able to. We may look at it as what we call a composite object. The next one, well, we have no choice but to use the first method here. We add the length of each one of these dimensions. That will give us a perimeter. So the perimeter be equal to 4 feet. Now when you have means feet, I'm starting from here, I'll go clockwise here. Plus, it doesn't matter. I could have started here or here, go counterclockwise. I just like to do it in sequence so I wouldn't miss any. Plus 5, plus 3.4, plus 3.5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Add all these up now. I am going to go straight to my calculator, make sure I get this all done correctly. Yeah, 4 plus 3 plus 4.2 plus 5 plus 3.4 plus 3.5 gives me 23.1. That'll be feet. Or if you'd like to write it out, now the next shape, we can't put a name to it. But what we know, we can break up or we can give section up this shape. We know how to find a rectangle, the area of a rectangle, the perimeter of a rectangle. We can do that. Now, later on, I'll show you when we have find the area, we have to section it up. But right now, because we're asking to find the perimeter, we don't need to section this up. But we have a missing, we don't have a value given here. So we need to determine that value first before we find the perimeter. So the perimeter, remember, is a distance around the shape. So we add up all of the lengths, but we're missing the length here, we're missing the length. So the dimension, the value of dimension here and here. So how do we determine it? Now, the length from one point to point A is the same as the length from here to here. So if I were to put a line through here, I could find, so you see, man, now this length here is the same as the length here. So to find this now, we know from these 2 points, here's 8 feet, or 8 inches. This here is 9 inches, and here is 2 inches. So now we can add these different dimension, which is the sum of these would be equal to the dimension here. So 8 plus 9 17 plus 2 is 19. So this is 19 inches. So here we have that. The next one, it's this dimension here. We don't know. So we have 10, we have 19, we have 6, we have 2, we have 3, we have 9. We're missing this one now. Now, here we go. We know this length here is 10, is given. We also know that the dimension from here, if we go from, this is 6, sorry. So we have 6 here. So if you put this across already here, across here, we know this will be 4. Let's put it here. So this will be here is 6, but we know from this point to point here is the same as this point here. So this will be 3. And we know the other, this would be 3 because this entire dimension here is 6. So we have 6 here. Oops, put it here. This is 3. So this from here to here is 6, therefore it will be 4. It's a little bit tricky one to determine. So this entire dimension here is 7. Now I'm going to rewrite this in. I'll put the 3 in here. It's 4. So the outside is 7. So now we have all of our measurements. So perimeter now will equal to I'll start from here, 19 plus 6 plus 2 plus 3 plus 9 plus 7 plus 8 plus 10. Now, get my wonderful calculator here to make sure I got this done correctly. We have 19 plus 6 plus 2 plus 3 plus 9 plus 7 plus 8 plus 10. It gives me 64 inches. Now we are moving into area. And this is where we are going to refer to our formula sheet. In this case, we have area of a circle, area of a rectangle, which is length times the width. Area of a square is the length times the width, or the side times the side, because all the sides are equal in a square. The area of a triangle is the base, for this b, times the height divided by 2, or half base times height. The area of a circle is pi r squared. Now, the perimeter now is referred to of a circle. Now, the previous questions we looked at, we have a rectangle and and two irregular shapes. When we look at circle, the distance around a circle is called the circumference. And it's a special name. So the distance around here we call the circumference. So if you can point to that, the distance around the circle is called the circumference. But the distance around the circle, we have a special formula for that. And it's C equals 2 pi r. So what this means is the circumference, which is the distance around of a circle, the circumference of a circle is equal to 2 times pi. It's wonderful there. Now, pi is approximately 3.14159. Now, you will use your exact value in your calculator. Depending on your calculator, I have one here. I'm going to use my value of pi. Now, second. Now, this is an irrational number. It goes on forever. There's no end to it. At least no one has found the end to this. A non-repeating decimal. There's no repeating decimal in the value pi. I'll talk about how pi came about. Times the radius. The radius is the distance from the center of the circle so the radius is the distance from the center of or the length, I should say, the center of the circle to the circumference. So that is the radius. Now, if I were to extend this a little bit further, it becomes a diameter. The diameter is the length from one end of one point of a circle through the center to the other side. That's the diameter. Now, there's a whole long history regarding pi, but the pi is the ratio, if you were to measure the circumference, any circle, doesn't matter what circle you find in the planet, just if we were to measure this precisely, then measure the diameter, which is the length from one end of the circumference to the other through the center. It has to go through the center. It's the longest distance or length within the circle, in the diameter. If I were to take the circumference divided by the diameter, you'll end up with pi. In other words, circumference divided by diameter is equal to that number. Doesn't matter what circle you use, you'll end up with that wonderful number called pi, even with a special name. Right? So if we are going to find the circumference, then we can write it as C is equal to 2 pi r, make it look less cluttered. So this would be a perimeter. So more or less the circumference is the perimeter. So circumference is equal to 2 pi. The radius is given as 10 meters. I'm going to have to go to my wonderful calculator, and I'm going to punch that in. Now, use the pi button in your calculator. Now, if you don't have a calculator, you may have to approximate it using 3.14, but you will get a precise answer. So 2 multiplied by, now I'm going to use my pi button. Now, In your calculator, you may see 3.14 and it goes on forever. What's most calculated, you'll see the symbol pi pops up. That represents 3.14159. Multiply that by its radius, which is 10. And that gives me a measurement of 62.83 meters. So C is equal to, let's go back, this is my formula. Now, on to example 4. Determine the circumference of a circle shown below. Hint, you have been given the diameter of a circle. The diameter is twice as long as the radius. You need to divide the diameter by 2 before you use the formula. Now, going back to our previous example, we know that the circumference is 2 pi times the radius. So let's write down what's given. Now, for any one of these, we need a radius. I'll write in the word radius here. So what is the radius? We're not giving it directly. But what we're given, this is our diameter. They also give us a hint. The diameter is twice as long as the radius. So we need to find the radius. So the radius is equal to the diameter divided by 2. Another way of looking at it is the radius is equal to half the diameter. We need the radius. We already, and our form is 2 pi. And what is our radius? So write it down here. 2 pi r. So my radius is equal to the diameter, which is 6. So radius is equal to 6 centimeters divided by 2, which is 3. 3 centimeters. Put my calculator here. We have 2 times pi times 3 gives me a measurement 18.85. So I need to round up to 2 decimal places. So because the digit after 4 is greater than 5, which is 9, we increase the 4 to 5. So we have 18.85. So C is 18.85 centimeters. I'll just highlight this here. And we know the radius. Now we've looked at the perimeter of a circle, which is have that unique name of a circumference. We are going into looking at the area. Area measurement is the amount of space within an object. For example, if I look at this sheet of paper, I would like to find the area of the sheet of paper. I look at the space within it. But the space within it are determined by the length and the width, or the perimeter of this object help to shape what is the area. For example, this when we have 6 centimeters is your length and 4 centimeter width, that's now determine how we'll find the area within here. So area is not only measured in square units because it's number of squared. For example, if I were to remove all of these here, there's no grid here, I would have gotten this in the beginning. I would have a shape like this here, 6 centimeters. And here we have 4 centimeters. And I'm asked to find the area. The area now, what I'm looking at, we measure the area by the number of squares within it. Here we have 1, 2, 3, 4, 5, 6. So we have 6 squares on this side here. And then we have 4 squares coming down. If once we construct a grid, we can count these squares, and that will give us the area. That is why our area is measured in squared units, because the number of squared, in this case, it is centimeters. If this was feet, we'll have square feet. If this was, we have 6 feet here, and I have 4 feet here. So we have 6 times 4 is 24. We would say this area here is 24, 86 centimeters multiplied by 4 to the power of 2. That's how you write it. Or you can record it 24 square centimeters. This is standard way of writing it, 24, or in centimeters square, or it could be meters square. In this case, it would be 24 square feet. To help us to find the area of any rectangle, triangle, or a circle, or a square, we're given the formula. And this is something you could put down in your study sheet to help you go along. But you have this at the back of your booklet. As I mentioned, it's in the same sheet here. Circumference of a circle. And then we have formula sheet we'll refer to. So the rectangle is the area is length times the width. A triangle is the base multiplied by its height divided by 2, or the base times the height, half of it. The square is length times width, or side times side. And a circle, now be careful with this, in a circumference of a circle is 2 pi r, but the area of a circle is pi r squared. That was radius times radius multiplied by pi. So recap, area is the amount of space within a confined dimension, and that dimension determined by its perimeter. Let's look at a few examples here. Example 5, you're asked to find the area of a triangle. So step 1, we record the formula for a triangle. Now, and this is where you refer to your formula sheet here. The area of a triangle is half base times height, or base times height divided by 2. So we record that here. Area triangle is half the base multiplied by the height. Or some people refer to as base multiplied by the height. Let's put a bracket around those. Divided by 2. The next step we want to do, step 1, have our formula. Step 2, we label our shape, in this case a triangle. So this is my base, and this is your height. So we record our height. And base equals 4.5. Then we go back to our formula. Area base times height divided by 2. Base is 4.5 multiplied by 3 divided by 2. Then I'll go to my friendly calculator here and work it out. So 4.5 times 3 equals, which is 13.5 Notice centimeters times centimeter square divided by 2 equals, okay, I'm going to make sure to separate these, 6.75 centimeters square. So the area of this triangle is 6.75 centimeters square. Step 1, write your formula down. Step 2, label your triangle. Step 3, write down your dimension. And the next step, we substitute our given values into our formula and solve. Determine the area of the circle below. In this case, we are asked to find the area of the circle. So we go to our formula sheet, and we're given the area of a circle is pi times r to the power 2. So we call that area of a circle is equal to pi r radius to the power 2. In other words, radius times radius. We record it as pi r squared. Or radius is given here. So given radius is equal to 2 centimeters. My formula is 8 pi r squared. Substitute 2 into my radius. By the way, this is to the power 2, meaning that's multiplied by itself. So area, got my calculator here. What will we get here? Now, I can work this out at 4. That's 2 to the power 2 would be 4. We can say pi multiplied by 4 because 2 in my case, I can put that down, it's going to be 4, times pi. I'm going to use my pi button, which is 12.566. So we round that up to 2 decimal places to 12.57. So area is 12.57 centimeters square. Our final example in this lesson determining perimeter and area is to find the area of a square. Go back to our formula sheet. We're given an area is length times width or side times side. We'll use both methods. This will be your length. Oh, and this would be your width. If you would have referred to as length and width. Area of circle, of square, not a circle. Is length times width. So length times width is the area of a square. Our length is 8 feet. Our width is 8 feet. 8 times 8 equals 64 square feet. We can also use the other formula, which is area side square. Let's look at that one here. So area is equal to S squared. This is S. So they're all, because the dimension are all the same. So we want to have, so S equal 8. So area is 8 centimeters squared, which gives us 64 squared centimeters. Same result. So to recap, today our main goal was to determine the perimeter and area of two-dimensional objects. And the two-dimensional objects, some have names, such as rectangle, square, circle, and triangle. And others we can't put a name to because they're so irregular in shape. Next, we looked at finding the perimeter of rectangles. And we said there are two ways of doing it. We can use a formula sheet, which is length, perimeter is length, 2 times the length plus 2 times the width. Or we can add the dimension around the rectangle with 4 sides. The irregular shape, we have no choice but to add each dimension around it on the perimeter. The third one, we have an irregular shape, which some missing dimension was given. So we had to section off part of it to determine the missing dimension. Then we looked at perimeter of a circle, and we said the circle is unique because it has a different, which is called a circumference, and the formula to find the circumference is 2 times pi times the radius. And we discovered that the diameter is half the radius. And finally, we looked at area. Area is a space within an object, and we used the formulas to find the area of a rectangle, half base times height. The circle is pi r squared, and finally the area of a square is length times width, or side times side.